Today we are going to try to see how to create a digital brain. Okay? We are going to see how we can make these LEDs, these motors, to only come on or spin when something happens. Remember I reminded us of this door that when you come close to the door, it opens. You go far, it closes. There is an electricity bulb. You see the street lights that they put on the streets. There are some, when you go close to them, the light becomes bright. You step back. Yes, so those ones now have what? Brain. They can sense. They can think. Sometimes you think that some of them can even see. Because why would you come close to a light and the light becomes bright? Why do you come close to the door and the door opens? Is it that the door can see you? So that means those particular objects have brain. They can think and act. The LEDs we used on the first day could not think. The motors we used on the second day could not think. But today we will see what makes things to think. Take note of this name. It is a microcontroller. It is the brain of systems. This thing is what makes things that are not human like us be able to think. So you can use this to make an LED to do what you want it to do. You can use this to make a motor to turn and to stop turning based on things that happen. And we connect this to a lot of other sensors and components and make them to act the way we want them to act. There are different types of Arduino. There is the Nano, there is the Mega, but this one is the Uno. So this is what we'll be making use of and seeing. You see behind there? These are what? Pins. These are the connecting points for the pins. Now, if you see the connecting points for these pins on the Arduino, it's just made for jumper cables to go in. So they have places for you to connect multiple jumper cables. Okay? Now this thing has 3 different sections for the pins. You have here, this part here is called the digital pins. Digital means 0 and 1 digits. You have digital pin, zeros and 1, all numbers. Okay? Then this smaller part here, this short part here, these old ones here are digital pins. These short ones here are called analog pins. And analog means it takes a range of numbers. You will come to understand why they are like that very soon. It takes a range of numbers. So in analog pin, you can get 0.1, 0.25, 0.37, analog, a range of numbers. Then this last part here, this part is divided into 2. The side that has this black one. These are analog, these are the power pins. So we have the power pins. We can use it to tap power from this, to give power to it, because this thing needs electricity to work. That is why you have this power jack here. The power jack, you can connect an adapter to it, plug it to a light, it will give this thing power. You can use this type of USB also to power it, which is what we'll be using. So if I connect this to this point, you see, the Arduino is powered. It is on now. So with this, I can do a lot of things with this. This is the programming part of robotics. It is the programming part that will make both the electrical part and the mechanical part to function the way we want it to function. This here, this is the real microcontroller. This thing you are seeing so is a computer on its own. It is a brain. This is where it stores the information and logic is built from it. When we were doing direct connections to battery, what were we having? The light comes on and goes off when we disconnect the batteries. So now that all these LEDs, you see the LEDs, they are all connected to the Arduino and they have been programmed to do something. Now let's see how these LEDs will behave when we power the Arduino up. Is anybody switching on and off? It is because a code has been written into this microcontroller that this LED should behave like this when light passes through them. And how this thing works is that this is taking in electricity and powering the board. Now these are the digital pins. This thing at the middle, remember what it is? And we know what it's for. Control excess power from going to the LED so that our LED does not get burnt. Alright, now it has been connected to the positive side of the LED, the same way we connected it the other time. No changes. And these yellow wires are connected to the negative part of the LED. You still remember our connection? We did it for just one, but now it has been connected to 6 different LEDs, 6 different resistors, and 6 different wires. Positive wires and negative wires. Now these are the positive wires. The wires that are supposed to be connected to the positive parts of our battery terminal. And you know, when you connect the negative and the positive of the LED through the resistor, the LED comes up. Now these digital pins that I explained to us earlier is now giving 5 volts. It is taking the power that is coming from this system on this, and each of these pins is giving out 5 volts. That is why we are connecting the positive of the LED to the Arduino. Does it make any sense to anybody? So these are the negatives, these are the positives. All the negatives are connected to one point. So, and this one, what did I call this part of the Arduino? This is digital. Good. So you see that the negative that these LEDs need is coming from what? The power. But the positive that each of these LEDs need is coming from here. Digital pins. So each of these digital pins is giving out 5 volts of electricity, just like the positive part of our battery. And it is because these pins, these LEDs, they are positive, are connected to the digital pin. That is why they are now receiving power. Now I want us to see what's happening. This is coming on and off at a certain interval. That's what's happening here. There's no specialty here. It's just you come up after the seconds, you go up, you come up like that. That's what we wrote in the code, that you are seeing it like this. So these are taking 5 volts on and off from digital pin 0 and 1, 0 and 1. So if I don't want to call it 0, what do I call it? If I don't want to call it 1, what do I call it? Is it making any sense? You can call 0 low and 1 with what? Very soon we'll do a project where when you clap your hand like this, the light bulb will go off. Then you clap it again, it will come up. Now this is serving as what? The brain of this thing. And it is controlling how these LEDs come on and go off and how they behave. Alright, work together as a team. Hello. Hey. Shift it that way so that some people can look from the other side. They are the ones that okay. So I don't want this LED. Yes, I don't. Remember, this thing does not depend on only the. What do you want? Okay, and there is no other points here. So what we can do is let's see if we can share 5 volts. One of these LEDs is the do you understand that? So if I connect this LED, let's use this one. And ground means negative. So you are picking negative ground. Programming was sending 5 volts to pins 3 to 8. Now you're not connected to 8, but you're connected to 2. So 2 is not receiving 5 volts. So if you want it to work now, hold it down. When you move this one,